Dear Internet, hello Internet, dear ladies and gentlemen, welcome to this last session of the Media Week at IFA. You're here right now at the Media Science Fiction panel, and it's all about next generation interface for content and navigation. So what is going to happen here right now in the next couple of 2 hours? So we want to discuss a few certain futuristic things right now. The digital revolution is at stake. People find out more technology and new perspectives how to use technology and how to create different content. Just 30 years ago, we had Tron, and Tron is a nice movie. And at this time, it looked like that. Right now, in the year of 2013, this is a 4D scan of a guy, and he put himself into a virtual world right now. And there are other stuff happening right now in this moment, actually. This is a German guy, and he released this movie 3 days ago. So right now he has kind of a thing called Oculus Rift on his head, and he is in a virtual world, and he can see himself. We're going to talk about semiconductors, which is magic for me, but we got experts here at this level, and the exponential growth is still at stake. I mean, 20 months it is, so to say, for the exponential growth, that semiconductors getting smaller and better all the time. And as you can see here, maybe it isn't so far away that you can get computer chips into our own body and enhance the capability of humanity. As we've seen in the $6 Million Man, this is from 1973. They had cool stuff as well, but it looks different right now. And the form of visualizing new stuff and new technology, we have experts on this level as well, and we're looking forward to those guys who create with new technology visuals that we haven't seen before. So this is everything what's happening right now, actually. Welcome to the Media Science Fiction panel, and as Arnold Schwarzenegger would say, the future is now. Yes. And we'd like to start our panel with Mr. Paul Hubmer. He's General Manager Identification Infrastructure at the company NXP. Please give a warm welcome to him. And he's talking about invisible interfaces. It's all about creating personalized moments. Thanks.
Thank you, Daniel. Thank you. So, good afternoon, ladies and gentlemen. So, my name is Paul Hubmer. I'm based out of Gradkorn, Austria. Still, I will speak in English. Sorry for that. It's easier to understand me when I speak English. What I want to talk in the next few minutes is about personalized moments. So when we talk about personal moments, I'm thinking about the environment reacting to me. Yeah, it's not only me interacting with the environment interacting to me. If you look back, movies came up, like, I don't know, 100 years ago or so. So there were the first commercial movies, like long movies. That was the start, yeah. It got better with TV, yeah, in the 1950s when TV came on. It was the first step of making me select maybe more than one channel. I could interact by choosing which kind of content I want to see, but still it was a pretty unidirectional way. It was not bidirectional in any way. When it became a little bit bidirectional, that was in the 70s with the first gaming consoles, so we could interact with something on the screen. We could produce content ourselves, and that was really nice. So I remember when I did my first video experience in black and white with lousy sound, but it was me. I could see whatever I do on the screen. It was really, I used the Commodore VC20 for those kind of already there those days. In basic, programmable, 3 kilobyte RAM, so amazing. Yeah. This microphone has more horsepower, I guess, today. So, but let's do a fast forward. Let's look at the 21st century. Yeah. Now, what do we have now? We have a massive enhancement in kind of computing power, in software capabilities. We have SDKs. We have hardware which we could never dream about. If you talk about TV or visual things, yeah, think about the screen resolution. Yeah, and I have a small comparison. Yeah, the first things had a size like this. Yeah, then the DVD came, HD ready. Yeah, we got HD ready. I'm still HD ready at home, so I'm prepared. Full HD, but kind of that's 4K. This is what you see in the other building, no? The calculation power that we have for this, yeah, I mean, every smartwatch that you see also in the other has more calculation power than the famous NSA had in the 70s. No, so it's amazing what we have around. Still, personalized, I don't know. Yeah. So of course, games, movies growing together mainly via merchandise. Yeah. So you see a lot of reuse of content in various ways, but the interactivity is still not there where it could be. Yeah? So Mr. Spielberg made a nice comment, and forgive me if I read it. Yeah, but the essence is just, yeah, it's about as long as we look at the square thing, yeah, it's not immersive enough. It's not we are not there, yeah, yet. So what you also see and at the show, yeah, Sony doing a lot of things with the head-mounted displays. There's a lot of hype on the Internet of various things, so it's getting better. Still, yeah, what I'm still missing is we become part of the virtual world more and more, yeah? But what I don't see is that the virtual world comes out of the screen into the real world, yeah? That could be interesting, yeah? So I want to see that objects break through the screen, come to my home, yeah? Come to my living room, come again to my comfort zone. So I'm using objects, I'm manipulating physical objects, and I see the reaction in the virtual world. So that would be, I think, the next big step. And you see first attempts also there. Yeah, you probably heard about things like Activision and Disney do with the Skylanders and Disney Infinity and stuff like this. So I think we are getting there, but I think we can do much more. Yeah? And again, the more we manipulate physical objects, I think the more we become really part of it, and not only participating a little bit, but we are part of it. Our body, our objects, our everyday objects become part of it. And again, it's not the living room only. Yeah, it's the first thing where it will come, of course. Yeah, because it's the center of our entertainment and media consumption. But if you look at like on the outside, yeah, if you go shopping, yeah, how could be interactivity? How can be personalized moments there, like in the shop? And we prepared a small video from a British company. The name doesn't matter, but it's probably interesting how they wanna present themselves. Yeah, now it's working. So I think the interesting thing on this video is not so much about these great bags and whatever clothes you can buy at the shop. It's about how they manage to get the pieces that they want to sell, yeah, and make it part of an experience, make it interact with screens, make it interact with all kind of displays, and therefore give much more value to visiting the shop. Yeah? I think that's an interesting point. With this technology, where you can have things interacting with other things, the value of going to the shop goes up again. Yeah? So we all see a big trend towards internet shopping, yes, but I think if you make the shop experience better, people will like to interact with the things they buy in advance, buying them. Yeah? So that can be a big thing for the physical retail market again. What you also see in this video, that technology itself is not in the background. So this is not an advertising for a great new 928 megahertz RFID with the latest readers. No, although it was there, you didn't recognize. So the technology is very much in the background. It needs to step back. Yeah? Then it's usable. Then it can be accepted also by people. We have another small example, which is completely different thing. It's about street lighting, personalized street lighting again. A short movie showing you what you can do if you create personalized moments.
One of the major problems with existing street lights is that they burn all night, even when there is no one around. And this is a big waste of energy. In my previous job, I used to fly a lot, and I was amazed to see that there is absolutely no one around and how much street lights are burning. Twilight is all about intelligent street lighting. What we have designed is a sensor that can fit into existing street lights and does basically two main functions. One, it dims the light during off-peak hours, and as soon as any occupants is detected, all the surrounding lights glow to the full mode. And that's a beauty, that whenever there is anyone, they should feel everything is normal, but actually they are working in an intelligent zone.
Yeah, so here, it's maybe not about personalized, because the light is pretty much the same for everyone, but it makes you feel recognized when you walk or drive along this one. So I think that's a big thing on top. And of course, if you do a lot of data thing in the background, you could even get your own personal light tune if you wanted. The last thing I want to show, it's again in the context of roads. It's about making the driving experience in general more personalized. Again, few moments video.
All around us, the products we use in day-to-day life are becoming more and more connected. Even the car is evolving from a traditional mode of transport to a personalized mobile information hub. Our car radio tuners, DSPs and amplifiers are designed in at 19 of the top 20 automotive suppliers. And we offer the first dedicated software-defined radio solution for cars, covering multiple global broadcast standards. Around 1 billion car keys with NXP technology are out in the field. They are also evolving from simple devices to secure information gateways, making a smart connection with your mobile phone, letting you personalize your car, or remotely control your car from a distance. And with NFC, embedded near-field communications, information is synchronized securely. Our ATOP telematics onboard unit platform is already designed in at leading car manufacturers. It enables real smart urban mobility, driving global megacities out of the jam and allowing seamless transition between all modes of transportation, as well as delivering a major step forward in road safety. Car-to-X wireless communication prevents road accidents and improves the traffic flow, achieving new levels of road safety. All this requires reliable in-vehicle networking. NXP transceivers cover all major current and emerging standards, and this is backed up with a broad portfolio of dedicated automotive devices. Instead of talking about what if, Start test driving NXP's secure connections for a smarter world.
I think the big question that I have when I watch this is, do I want that? The car is connected inside the car, outside of the car. Cars are talking to each other. There's a lot of data generated when things, especially devices, talk to each other. They can talk pretty fast and talk a lot without a lot of sense from time to time. So who is protecting my private data? Yeah? So when we talk about personalized moments, we all like the idea, but we also don't forget, whenever we talk about personalization, that means I need to give out information from me, things that I like, things that I don't like, things that I prefer, to somebody else that does the personalization for me. Yeah? So we heard in the opening speech a lot about playlists yesterday morning, and I was feeling a little bit, of course, playlists are really wonderful, but it really allows people to get a psychogram. So my private playlist says a lot about me. Yeah? So how do we protect all this information? I think that's a big, big thing, next to the connectivity aspect. So I think we all agree connectivity is great and it makes the world better, but if we don't manage to secure this connectivity, if you don't make sure that information is only available to people that should have it, and there was many discussions, even governments involved in which information who should have, that's the key thing. And ultimately, it will also be the gatekeeper for adoption of this on a broad base. Yeah? So it's great to have technology. We can make it usable. We have a lot of experience on usability, and all the companies work on this one. But if we fail to secure all this connectivity, that people have peace of mind in using this connectivity, then the whole thing simply will not happen. Yeah? And we see that as a security company also, so that's a part of our business, that many customers that said connectivity is good enough 3 years ago. Yeah, just give them the connectivity chips and we take care on the rest, and now come back and say, maybe I want a little bit of security on top, else people refuse to use it. Which is good, because I think it shows that the market is educating. It's good for companies like us in the security business, obviously, but I think it's an important precondition. Yeah? And security has even higher demands on usability. Yeah? So you all enter very long pins on your phone, don't you, in order to make sure your phone is kept safe. So if security goes against usability, we have a big issue. I think all this technology, being connectivity and security, it's only adopted, as I say, needs to solve a problem that we have. It needs to be secure, it needs to be usable, and I think the last one is the biggest. Yeah, the last one should not be an excuse for a trade-off of the first two. Yeah? That's important. So, kind of, in general, I think technology that is developed has no own purpose. Yeah, it's not about taking over our life. It's about supporting our life. Yeah, and if we use technology right and we use it in the right mix and with the right balance, I think we can make the future, which has already begun, and I fully buy into that. It's kind of now. Future is now. It can make it more intuitive, smarter, and really personal. Yeah, and that's what we look for. Thank you.
Thank you, Paul. Incredible. So I have to tell and say to you directly, this is all magic to me. So I can understand what's happening. I have a smartphone in my trousers here and then, and it can ring. So this is what I can understand. But maybe we have to clear things up. So NXP is a company who produces 1/4 of every semiconductor worldwide. This is correct. So in every semiconductor, those are the magic thingies that can do stuff like that, right?
Indeed. So we are one of the top 10 semiconductor companies on this planet. Not in memories. That's why we are not on the first ones. But various active in various markets like identification. So the thing I belong to, it's about security of objects and people. That's our core business. But also things like automotive, like you saw in the movie, standard products, all kind of crazy chips.
So actually it is sci-fi. So you got the near field communication. So when I put my phone next to another phone, then they can communicate. As you said, sometimes it's senseless that they communicate. I don't get that. You have to explain that to me, please, maybe later on. But for all the audience here, you got the smart cards already. So this is magic for me again. So you can just put it onto your phone and then you got your contact cards. Let's talk a bit about more security, because you said it as well. And I mean, this is a huge worldwide thing right now. The NSA is watching us. Who are they watching? And we all don't know. Are we watched right now? We don't know.
We hope.
We don't know. Maybe, yes. So what can you tell us about that? Because behind all this being watched are computer chips, are semiconductors, are smart devices who's doing that. So what can you tell us about this? So how difficult must it be to secure things like that, like this near-field communication or global communication?
I think in general, the methods of securing data are well known and well proven. So I think there is no magic in securing data. I think the biggest obstacle we face today is that if you do serious security and apply this technology, it really eats into usability. Like if you decide to encrypt your phone, which is in general a good idea, performance will go down. If you encrypt your hard drive of your computer, performance will go down. I think this is the biggest obstacle at the moment for making it, let's say, broadly available. The security technology itself is based today no more on proprietary kind of security by obscurity methods, but published standards. So the brothers of the NSA, the NIST, so the standardization gives out the latest crypto standards and so on. You just have to apply them. There's a lot of research on them. So security is available. You have to implement it correctly, and you need to implement it in a convenient way.
All right.
Then it's us, the users, of deciding, do I use it or not?
All right.
So plain text emails that people can read it should not surprise anyone. So. It's about awareness, I think.
I guess so, yeah. So just one more question from myself, and then you could ask questions as well. We've seen the commercial, or the kind of commercial with the shopping, and you go inside, and then you got lots of shopping ads personalized on me, so I could walk into that shop and see myself in really fancy suits. Is there going to be an ad block for that? Encrypted stuff, that's what you said. So,
exactly. It's about how much do you want to give out yourself. And I think there's a big discussion between opt-in and opt-out of such schemes, which is always there. So I actively have to register as an act of will. And like proximity technology can be part of this. Like if I put my phone here, then I did it. I put my phone here. It doesn't work from here. So I can opt in a convenient way. And then I'm part of the shopping experience.
But you don't have to do it. So.
You don't have to do it, exactly. And this is why these opt-out things, where you have to say, no, I don't want, actively, that's a little bit more difficult. But every culture has a different default, let's put it that way.
All right. Thank you very much. Those were my questions. And let me ask the audience, do you have any questions at Mr. Paul Hubmer about the future of computer chips? Is it magic to you as well? Okay, there's a question.
Thanks for this amazing keynote. I have the impression you're thinking a lot about the direction security versus usability. Just came to mind with me at the moment in democracies, we are talking a lot about freedom versus security. Although it's not really the topic of this lecture, I think there's a tight connection about the philosophies you apply in your business to the usability versus security, and to keep democracy usable, how do we secure it?
Yeah, I think the big point is really, if there is technology available, and technology is available to secure the freedom of the independence, or at least the privacy, that's where it all goes to, of data. So I think we as technology providers, if we fail of making it accessible in a simple and cheap and standardized way, and also governments helping on this one, yeah? Like using national ID cards as a root of trust for secure encryption. Yeah, like it's partially done in Germany, as far as I know. Then that can work out. Yeah? But the average citizen, yeah, will be overwhelmed with the complexity of those schemes per default. Yeah? So if you ever try to install a serious email encryption on your PC at home, I mean, you need a little bit of preconditions to be able to do that. Yeah? And that's maybe the thing where more can be done. Yeah? To make the default encrypted and not unencrypted, to make it an opt-out of security, an opt-out of privacy, not an opt-in, which is today.
Okay, magic. So, any more questions? All right. So then, thank you again, Paul.
Thank you.
Have a seat. So, and by speaking of security, there was a huge incident a couple of weeks ago. It's a kind of side road concerning to gaming. There was the Xbox One, and the Xbox One was announced, and there was the camera called Kinect. And Kinect is using certain chips from PrimeSense, and just a short notice, many people disliked the fact that Kinect, the camera with PrimeSense, could track a lot of stuff like heart-beating stuff, etc. But the possibilities with this technology, we want to discuss that, and we have a little short movie to show you what's up with PrimeSense or Kinect. So the next speaker will be Mr. Minaj Mukhtar. Let's show the movie, please. So as you can see here, there's a little boy, and he's eating butterflies. And he's not eating butterflies directly, but virtually. This is Kinect, and this is Kinect used really creatively. So this is a camera, and it can sense your movement. And this is a guy, and yeah, as you can see, he uses Kinect to use a robot cutting a banana. This is a really creative stuff, actually. So, and the guy behind this is Mr. Minaj Mukhtar. He is Vice President of Sales, EMA and APAC. Welcome, Mr. Mukhtar. Thank you very much. It's your stage. Thanks.
All right. So, thanks. Like Daniel said, my name is Manny. I'm doing sales at PrimeSense. And today, I would like to share with you where we think the TV and the TV market are going to go and going to be in the near future. And since we are at IFA, I went to the first keynotes in the first days of the show, and I found this one from the CEO of Vestel that says basically the same thing. We will still have TVs, they will still grow bigger, but probably the industry will have to change, and nobody knows how much it will change into what direction. So we all agree on the size that will remain bigger, and the debate is on what roles and functionalities the TVs will have. And I think every TV manufacturer is brainstorming on this. Number one, with the TV will still remain the end point of the content and only be a big screen to show us the end result of the content, just a display. Or whether the TV itself will become interactive or generating the content by itself. What about the whole experience of watching in the living room the whole family together? Because right now the trend that we see is that more and more the watching and the viewing become more personal. I have my kids, each one a teenager, going to his room, closing the door and watching a movie on his tablet or his mobile phone. With a very good quality of the screen and zapping to WhatsApp groups and stuff like this. So is it still going to be a family-like thing in the living room where everybody gathers around the TV? And if you go in the other side, at the halls, you can see LG, Higher TV. They're trying to benefit from both worlds. So now they have TVs which can show you 2 videos at the same time. So you can get together with your wife watching one thing, you watching the other thing. I don't know how much it is for gathering, but the technology is there and people are showing it. So there is a debate on where the TV is going and what part it will play in our living room. And I will try today to share with you what we think or where we think it's going to go. And this vision is based on two things or two major pillars, if you like. One is the interaction, the user interface with the TV. And the second is the content itself. These two, we think, will drive the position and the role of the TV in our living room. We'll start with interaction, with the user interface. And I know every stock market guy will tell you that it's very dangerous to look on the past in order to understand what the stock is going to do next in the future. But here I will allow myself to look at the past a little bit to understand the future. Now, in the past, every time there was a big leap in user interface, the product opened, or this leap in user interface, this jump in user interface opened for the product new markets and new consumer base. It enlarged the user base of the product. We can take, for example, in the late 80s, beginning of the 90s, when Windows and mouse came out. Suddenly, my grandparents, which were basically at the beginning afraid of this new technology called PC and computer, suddenly they were able to use it. Because now it's intuitive icons with a picture on the icon that can say what it is. And they just move with the mouse and click on it, and they open the application. No need to write, like in the DOS days, .exe, and to know that only exe file is something that runs. So suddenly, the old generation was able to use PCs. So it opened a new population of users for the PC. That's a leap in interface that brought new users. Then, in 2006, Nintendo came with the Wii technology. And suddenly games were not just for, very sophisticated guys who know how to handle 2 joysticks and 5 buttons at the same time in order to punch and to kick and to kill the enemy. Suddenly, also started content that is able to run without all this. You cannot do with a joystick a yoga. But when you have the Wii Fit, you can have a yoga content and you can do yoga. So it opened new directions, and because of this, also my mother can play. She takes it in her hand and she does like this and she plays bowling. She couldn't do it before. It was only for gamers. And that's, again, a leap in user interface who brought a totally new population of of customer base to the games. And then a revolution which we are still experiencing, it's the touch. So this came along, and we do things that are much more intuitive. When we want to zoom, we do like this. We want to zoom out, we do like this. We click, we move. And think what population this brought in. When I was a kid, or when my kids were still kids, whenever the baby was crying, the 2 years kid was crying, you give him a ball or a doll or a truck toy. But now I sit on the flights to Berlin, and a 2 years baby is crying, and they give him an iPad, and he can play. So it opened, but that's life, guys. So maybe the Windows brought the upper hand, but the iPad and the touch technology and the interface brought the kids and the young guys and the babies. So now again, it opened a new population of users for this equipment, for this type of users. And then there was the Kinect in 2010, and that even brought it further. Because now you don't need to actually touch the screen, and you don't need any mediation device, like with the Wii, to interact with the game and to interact with the content. You stay as is, and you can interact with the content. So when you want to jump, you jump. And when you want to bend forward or sideward or whatever, you just bend. And the device knows how to understand you, and you interact with the game. So that's, again, brought new, or increased the user base. The user base brought more population for the gaming. And if you don't believe me, you can see what Mr. Ballmer said, here celebrating 8 million sales of Kinect within 2 months. At that time, that was a Guinness world record for a commercial electronic device sales within a given time. So again, a leap in user interface, in user interaction, increased the usage of the specific equipment. Okay, so like I said before, a leap, we agreed on this, that a leap, a user interface jump, a good user interface can increase the usage of the equipment. Now that was the first pillar that I spoke about before. Keep this in mind. We'll connect it to the other one at the end of the end of the session. In the meantime, let's see what happened with TVs. So we had the TV with the big tube with the mechanical tuner to change the channels, and then we had cable TV and interface directly to video signals. A big thing was the remote control. How did we live without it before? And then there was the connected TV, and now we have the smart TV. There's nothing out there in the second hall that is not smart. Everything is smart TV. And today's TVs are cracked with processing power. They have dual-core and quad-core processors. Now, there's a common rule of thumb in the industry that there is about 1 to 2 years left or past. You did 10 minutes. So there's about 1 to 2 years time lag between the processors that goes into mobile phones until they reach into the TV, because the mobile phones are changing much faster. I have Galaxy 3, and it's a quad-core A9, and it's already the S4 is out. This is the S3, and the S4 is already out. So this will be available for sale maybe for another half a year or a year. But the production line are still crunching the chips, and probably this chip will find itself to one of the TVs. So the TVs are getting more and more power. The operating system are standard, and standardization, we know, helps to increase the distribution, because they are standard. Anybody can build application for them. Anybody can build games, application, content, because it's the standard operating system. Yes, the Japanese, the Koreans, they like the Linux. The Chinese, the Europeans, they like the Android. But it's standard operating system. And because it's standard, it's open to everyone to add things to it. So when you have the processing power on the TV, basically you don't need the host computer to run the application. So we have all this power, and what we do with it today is basically we only are watching channels. But the TV itself has the power to run its own applications. The TV itself has, if you like, a community, because it's Android-based. And excuse me for concentrating on the Chinese side and the European side of TVs, but I'll concentrate on the Android. And basically, the TV can become the platform itself. So we think that since there's so much power cramped into it, and people will try to explain why there's so much power cramped to it and find ways to use it. And then the TV will be able to run its own applications. Okay. But there are currently, or today, 2 barriers. One is the TVs themselves are not yet gesture-based. They cannot interact with me just with my body and my hand waving. And number 2, there's not enough content. But this, what we think, is going to change. And it's going to change because we think, first, the TVs will become gesture enabled. They will be able to understand gesture. And because of this, people will start building the application for it. It's not so difficult to build the application because there are so many applications already that are Android-based. Yes, they are touch-based, but all we need to do is port them into gesture-based. But they're already there. Once the install base of gesture-enabled TVs will be large enough, then it will be an incentive for the content providers to port their content into the TVs. Okay. So just to show you the feeling of how it will look in the near future. Interaction with the TV, with your gesture, the same way you do with your mobile phone or your tablet. You want to move a picture, then you just swipe your hand. And you want to choose a picture, you just click. And when somebody calls you on Skype, then you just click and pause and start talking, and then you can start again the movie or whatever program that you see. And you can call different applications, and you can use different things, and it's all with 4 basic gestures, basically. Left movement, right movement, swiping, clicking, and so on. Okay. You'll have to do escape in order for me to go out. Thanks. Okay, now, we don't think we are too much of a dreamers because we get signals from the field that this has already started happening. This is, for example, a 60-inch HD TV, UHD TV in China, manufactured and selling in China, which basically come already with gesture-enabled, and when it shipped with gesture-enabled Android games already loaded into it. So the user look at it and say, I have the HD, I have everything that other TV gives me, but I also have games. Games in the level of the Xbox, they are gesture-based, the level of the Kinect. They went for the quick and dirty solution. They didn't put the sensing device for the 3D, for the gesture inside the TV itself. They didn't embed it inside. They just took the existing one, built a female connector on the TV, took the cable out from the sensor, put a male connector there, and then they plug it in, and you have an integrated solution for a gesture-based TV. This I added yesterday night at my hotel. I couldn't resist it because yesterday I walked the aisles of the show, and at Hall 3 I saw a TV that is interacting with body gestures with a sensor, and I like the slogan they used, that your body is the control. So basically, you don't need intermediating device between you and the screen, between you and the TV. You control it basically with your body. Now, once you add to the TV the 3D sensing, the gesture capability, you can do much more than just playing games or using interface. Yes, you can have a UI. You can control the TV and the programs and move channels and so on. Yes, you can play game. But the TV gets much more. The TV can also recognize you by not just by your face, but your body metrics. What is the distance between your shoulders, between your head and your chest, and stuff like this. So the recognition is much better. And it can personalize the content and the offering of the TV to the person watching. So the TV, like you said, interacting much better with the person viewing, for example. Okay? What does it do? Maybe he's lying down and he or she lying down and fell asleep, so I better turn the TV to a sleep mode. Maybe the phone was ringing and he's actually placing the phone close to his ear, so I should put the volume down, and so on and so on and so forth. It puts much more smartness into the smart TV. Okay, that's comes the other part, that the TV can also be the creator of the content, not just the endpoint of the content, not just taking the content and displaying it, but because you have 3D sensing, you can measure people better, you can separate them better from their environment, and that, again, just a suggestion for a content to track your kids growing up and how much height they have month over month. And there's nothing in like this currently, so you don't go and look for it at the show itself. And there's no copyright on this, so if anybody wants to develop something like this, you're free to do. But I just use it as a concept that you can use the TV, once it's 3D enabled, to create the content and not just be the endpoint for the content. Of course, you can play games, and you can play games by skipping the game console, by skipping the box, because the TV itself can run the application. Something like we heard before about showing you how you will look with the outfit. So since it has 3D sensing, basically it can scan you, it can measure you. So if you want to buy, say, a piece of a shirt or a dress or pants on the internet, it can show you exactly how you will look in it and what size you need to buy. So let's see, for example. So you stand. No, you stand in front of the TV, which has the sensing device, and it can scan you, and it tells you the different sizes that are relevant. And then you go to the interactive menu of things to choose from: a dress, a skirt, a shirt, or a pants. And it will tell you what size of this specific model you need. And then you can see yourself how you would look with this specific one that you want to buy, whether it will be too tight at the hips or okay with the legs, and so on and so forth. And then you can click and buy. Okay, so that's causing you basically to spend more time in front of the TV. And this is, if you like, the dream of every marketing guy or product manager in every TV manufacturing company. Escape. I learned something today. Okay. Another thing is, and that's really for the TV manufacturers, this is from Xbox itself. This is for Microsoft. They say that the main, first of all, this game opened also the TV game more to, or the Xbox more into girls. It was more of a boy thing, you know, the killing and the shooting and the stuff. But this one, which is partly a game, partly a teaching application, where they learn how to dance and it ranks them if they make progress or not, was one of the main reasons where girls wanted the Xbox and this game. Now, why should only the gaming console guys benefit from it? A TV manufacturer can benefit from it as well. And that's another thing that might take a change. Maybe the TV makers will have to start to be content distributors or content promoters or even content makers, content generators. And not be only a hardware manufacturer. Now just think what happened with Google and with Microsoft. Both were purely software companies, but each one of them now is also making hardware. So maybe the TV manufacturer should go just the other way around, from being purely hardware manufacturers into somehow dealing with the content itself. That might be as well. Now, I have one more slide left, and I was told that every presentation should end with an optimistic thing. So I will try to be optimistic. No, it didn't work. Okay. The good news is that all this technology basically is available today. Okay. The first generation was the Kinect, and by the way, the first generation Kinect didn't read your heartbeat. It's the second generation, it's not us. So the first generation Kinect was big, bulky, and expensive. But the second generation, having exactly the same functionalities and features and spec, yet it's 10 times smaller. So it has a tiny form factor. It's so small that it basically can go into the TV bezel itself or the TV pedestal and be built in as a standard component inside the TV. And no less important, it's very low cost compared to the Kinect. So in this specific industry of consumer electronics like the TV, where every dollar counts, and there's a lot of competition and the margins are very low, it doesn't add much to the cost. Thank you.
Thank you very much, Manny. This is incredible. So you said the technology is here right now at this moment. But let me ask you the question, how far is this leap? When will the TV industry recognize these possibilities? What do you think? Is it like 2 months or 2 years?
So,
if you can talk about it.
Like you saw, there are some guys who are already doing it.
Okay.
Okay. They are the early adopters, if you like. To be honest, you don't see any TV there in the halls in the other side of this complex when this one is already inside the TV. They're all outside the TV. But like I said, I give you half of the solution. It's only a matter of time. How much time? I don't know.
All right. Thank you very much, Manny. I think we ran a little bit out of time, therefore no questioning. Thanks, Manny, again.
Thank you.
Interesting, really interesting. Yeah, and sorry for the heartbeat thing. I thought it was too complex, too magic for the audience. It doesn't matter, this is gaming. So okay, let's move further on, and I'm really happy to have two guys here right now, and they'll be on stage in a second. They will have a presentation about science fiction meets media production, and they are experts in visualization, and not only that, they are doing consulting for many companies as well. They are from Los Angeles, and we can show you a little bit of footage. This is mainly about them doing visual stuff. They're working together with lots of film industries and really popular bands, just like Marilyn Manson, which is not a band but a guy doing music. I know him, he's good. And maybe we can show some visual effects. So it's pretty clear. So the technology is moving further. There's an exponential growth in it. So cameras are getting better. You get 4K if you need it. It's a different discussion. But cameras are getting better, and the possibilities are getting more and more what you could do with all that stuff. So let's show a little bit of the footage of those guys. We have a tiny movie in it. That's it. So this is Marilyn Manson. You might recognize him. And this is just a little bit of footage of the Sturmgruppe. And I'm really happy that they are here. We have Alan Lasky. He's Director of Digital Operations, NSA OSW from Los Angeles. And we have Richard J. Piedra here. And I'm really happy that they are not only visual artists and not only that they're talking to lots of filming industry people, but they're gamer, and this is a good factor as well. So welcome on stage. Cheers, Alan. Cheers. I don't know what you're doing, but I'm looking forward to that.
Well, We're not going to talk anything whatsoever about what you just saw. We're going to take this in a completely different direction. When we were briefed on media science fiction, we decided that we really wanted to talk about some of the other work we do. And yes, we work on rock videos. Richard and I work together on many film and television projects and everything. But to be honest with you, that's getting boring. That's the last century. Working with Marilyn Manson and all of that, it's fun. We do it all the time. But that's not what we wanted to talk about here. We have a completely different sort of tack on this. So you ready?
Ready?
Let's do it. All right. So can we see our presentation up?
Yep.
Apparently not. We're not there yet. Science fiction and reality together.
The future is not now.
The future has not arrived yet.
Do we have output yet? What's going on?
We have a signal, but maybe we have to mirror them.
You want to run it?
We can't actually mirror the screen because we need the prompter. So we had an HDMI cable before.
Well, everybody
still
seems
have
to
that?
get very upset because my company, I have a company called NSA OSW. And NSA OSW, one of them, they're really just shell companies. One is for when I interact with the motion picture industry and the entertainment industry, and the other one is for when I do defense contracting and things like that. So we're going to show you a little bit of both. Right. And we're going to kind of go into both of those and essentially talk about both at the same time. But while we're getting ready,
Are you ready?
I think we're good.
Okay.
Okay.
Cool.
I was asking the funny question about NSA, but
Yeah, but it's
let's
not
do that
that
later
NSA.
on. It's okay.
It's not the NSA that's basically spying on us right now. That's basically tapped into our presentation and will arrest us as soon as we're done, which you will know why in a moment.
So do they just need to switch the input on?
The future. It's never as good as it's on TV. That's the problem. It's just never that good.
So you don't have the feed. Yeah, it's just a black slide, and then we've got text.
Okay.
Yeah.
Come on, we're from LA. It's black.
All right, so we got it now? Okay, good.
All right.
All right.
So, go ahead and give us the first title slide.
So we should have it. That's it. And this is, we have a signal problem.
So, Ellen, let's talk about the NSA thing again. Oh, I know OSW means open source warrior.
Yes.
That's correct.
Open source warrior is, you're going to see why we call it open source warrior in just a minute when we put the presentation up. Open Source Warrior is a project that we started a while ago, essentially to really get at, in the United States especially, we have a lot of really high-tech stuff going on in the Defense Department.
Yeah, that's right.
And we always really wanted to get at that technology. So basically, and make it more open source. Not because we wanted to blow people up or shoot people or anything like that, but because that there's some really good sensor technology, there's some really good optics, all sorts of really cool stuff that we want. And so what we did was we formed Open Source Warrior as really, to be honest with you, something that we could sneak into defense and military shows. So that we could get passes like these to defense and military contracting shows, so we could go look at the technology and we could go and essentially talk to these people that we wanted to talk to. So cool, but we're up. Let's go back to the first slide.
Let's go back to the title slide.
Thanks.
All right, thank you.
Okay, thanks. So what we call this is, if you go back one slide, what we're calling our talk is Killer Apps, Blurring the Line Between Science Fiction and Reality. And I'm Alan Lasky, that's Richard Piedra. We're going to go quick because I know we're running out of time here. So
okay, so next slide. We wanted to start with just a few quotes from some science fiction authors that we think are prescient. Alan?
Yeah, so the first quote that we wanted to bring up was Arthur C. Clarke said back in 1945, "The implications of this are obvious. We can now send instruments of all kinds into the ionosphere, and by transmitting their readings back to the ground stations, obtain information which could not possibly be learned in any other way." And then, that was in 45, and Sputnik 1 launched into an elliptical low Earth orbit on October 4th, 1957. The reason we're bringing this stuff up is because this whole talk is really going to be about how science fiction really did cross-pollinate with reality. And we work a lot in science fiction.
1 second.
clearly not enough.
Just keep going.
But,
Just keep going.
Okay, we work a lot in science fiction, and what we're doing basically is we work a lot in film, television, and we also work a lot in video games. We play a lot of video games, and we basically use that as a jumping off point for a lot of the work that you're going to see, hopefully. There we go.
The signal. Okay, that's back.
Okay, and so let's go to the next slide. Okay. So this
is a quote that we like because Ray Kurzweil basically said that the term virtual reality is unfortunate because it's still real reality. And what he was talking about when he said this was that this was from an interview where he was being interviewed about the evolution of Second Life, like virtual reality experiences, and essentially saying that once the computing power is there, these virtual world simulations will become indistinguishable from reality to the user in certain instances. And in keeping with the sci-fi theme, we just want you all to kind of keep that in mind as we look at these upcoming slides.
Okay, so one of my favorite authors is William Gibson. And Gibson said something actually really interesting, which is that the future is already here. It's just not evenly distributed. And I think that's really true. And you're going to see that's kind of the theme that Richard and I use throughout this whole thing. So I'm Alan Lasky. My background is I do visual effects. I've done a lot of cinematography, worked for a lot of companies like Silicon Graphics, things like that. But I also work as a consultant for high tech and have done a lot of high tech work.
So my name is Richard Piedra. I spent about 5 years working for Apple in software development and testing, mostly in the Final Cut Studio. Most recently, though, I worked for a startup company in Los Angeles that was involved in gestural interface development. And we're going to be talking a little bit more about that in the upcoming slides. And I'd like to just quickly thank Michael Liba for inviting us to speak at this.
So talking about our combined work, if we go to the next slide, we're going to really give you an overview here. And this is something that when Richard and I met a long time ago, we both fostered a real interest in things like video games, interface, science fiction, all of that. And we've been exploring what we call the porous relationship between interface design and science fiction and how that manifests itself in real-world applications. Now, this is an important word, porous, and my German is pretty terrible, but we wanted to see if the right word would be durchlässig. Is that the right word for porous, for when things cross cell walls? Is that the correct word in German? Okay, good. Then we nailed it. So basically, our experiences they span high-tech software, hardware development, and we also work in the entertainment industry and in video game and film. So you're going to see how all that comes together.
So collectively, we've worked for Apple, Silicon Graphics, Panavision, Oblong, DALSA, and others. We've been involved with projects ranging from gestural interface for government clients to content creation solutions for the entertainment market. And one more quote.
And Neil Stevenson actually has one of my favorite quotes. He says, besides, the interesting things happen along the borders, the transitions, not in the middle where everything is the same. So this is the durchlässig thing. This is where things start to meld together. Now, I'm going to put a caveat on this. This is going to get really insane right now, okay? And so basically what you have to understand is that Richard and I kind of don't take no for an answer when it comes to technology and when it comes to kind of, well, we see something and we like it and we want to use it. So the first thing we're going to talk about is target acquisition. We were very interested in the concept of electronic target acquisition as it has been visualized in video games. Now, the first thing that we really liked is Halo's sniper rifle. How many people play Halo? Anybody? Okay. Halo, come on. Halo is a classic game. It's already up to, I don't even know how many releases there have been. But we've been really big fans of this game. So what we did was we went looking for the closest analog in the real world. And this is where OSW came in. We talked our way into a military optoelectronics show. And we found in the real world this thing called the Digital Hunter, which basically is the first all-electronic rifle scope. Now, because we wanted to explore this porous border between these things, how would something that was in a video game work in the real world? So let's basically take a look at this. And let's take a look at the video right here. Now this is the scope in Halo. And it's all electronic, has a rangefinder. all of this, and this is how they visualized it in the game. So what we did was we went to this military show, we talked these guys into loaning us one of the digital hunters, and we basically went out to the range, and it has an electronic sight on it that basically allows you to do exactly what you can do in Halo in the real world. So there I am out at the range looking insane with the Alcan digital hunter, and we basically put, and there's Richard firing the digital hunter with the video. It's not me. So basically, now this is what we're talking about. We wanted to actually see these things that were in video games, how would they work in the real world? How does the cross-pollination of these technologies work in the real world? And Richard's going to talk about the science fiction and the movie part of this.
Yeah, so talking about the porous nature going from sci-fi to real world to back again to video games. A little bit about gestural interface. In 2000-2001, John Unikoffler was approached by director Steven Spielberg and production designer Alex McDowell, who were working on a film called Minority Report. And they had been impressed with his early gestural work at the MIT Media Lab in the late 80s and early 90s. And John was actually hired onto the film as the science advisor for the film and was responsible for developing all of the interface technology that you see in the movie. But, so I'll just roll a little clip from that. That's the headline. That's actually John, Alan, and myself just before he began work on the film. And then here's a brief interview with him.
Time frame? 13 minutes.
What he's doing now we call scrubbing the image, looking for clues as to where the murder is going to happen.
I think that experts and lay people alike watched the film Minority Report. And there was a certain level at which it wasn't necessarily clear which things were real for real and which things had been faked up a little bit. And so, of course, it was very natural for us as engineers to go back into the lab, back into a company, and keep building this stuff. But equally, I think it was the reaction of audiences to this stuff, whether they knew it was real or whether they knew that it wasn't. It made sense to everyone. It made sense that this is how humans and computers should relate. And that was a huge boost to us to sort of go back and keep building it.
Okay, and then for the science fact portion of this, what's fascinating about this story is that John, after work on the film, was approached by a number of VCs that said, can you build this for real? And his response was yes. And they funded and started a company called Oblong, based in Los Angeles, California. And I had the opportunity, a very unique opportunity at the time, to leave my job at Apple and go to work for Oblong. And this is some footage of the actual system being used, and this was a system that we installed in Saudi Arabia for the use in oil and gas exploration. And what you're seeing here is these are actually demo applications that we would run on the stack to sort of test the system after the installation and verify that it was working correctly. Okay, so for this next slide, this is where I think it gets fun. We just went from a science fiction novel written by Philip K. Dick to a Hollywood film to a real-world manifestation of a key piece of the technology visualized in that film. And now we're going to take you back into the video game world. And the reason why I like this clip so much is because I think that in a game, this was a very interesting visualization of a potential pointer to the future of these interfaces. And it's basically a combination of mobile augmented reality combined with mobile gesture recognition. And this is from Heavy Rain, and I think this was Sony and Quantic Dream, 2010. Okay, and what do we have next? So again, future direction. Now I'd like to just show a small excerpt from a demo video that we were really impressed with from a company called Magic Leap. And Magic Leap is a company that is involved with, they're a startup that's involved in the development of wearable augmented reality technologies they call cinematic reality. And we have a very brief segment that we want to show that we think demonstrates some amazing work and ideas which mirror a lot of, I think, what we've just seen and what we've talked about today. And this is kind of a visualization of what they think the future of mobile augmented reality will look like. Okay, and back over to Alan for some more situational awareness.
There we go. So one of the things I was actually really interested in, and that Richard and I were really interested in, is what we call situational awareness. Basically what the military defines situational awareness as is basically using sensors, whether they be UAV platforms, ground robots, laser radar scans and all that, to give you to use sensors to give you a wider awareness of where you are, where your team members are, all of that kind of stuff. And again, we were like, hey, this shouldn't be the domain of the military. We should be able to use this technology as well as people, just as individual citizens. So the first thing we're going to show you, one of the major influences on this was Fuel of War. And Fuel of War was a video game. And in here, you see there's a ground robot. And basically you're driving the ground robot around. And basically, of course, in this game, because like you were saying, it's the shooting and the killing. There's a lot of shooting and killing in this game. But we said, okay, the idea of having a ground robot that basically allows you to go out and see the world away from your own position is actually cool. So what did we do? I talked my way into a military robotics show, and we hooked up with these guys who built the SUGV, the small unmanned ground robot, and I got to drive the small unmanned ground robot around using essentially a game interface. And this is what's really interesting, and where the porousness of the development really comes together. And so we met these guys, we talked to them for quite a while, and I believe we have next up a short video that shows you how gaming was involved in this.
The controller that he's using to control it may look familiar. Some of your kids may use these. It is a game-style controller, and the great thing about that is it gives our soldiers years and years of training prior to driving the robot. So it makes picking it up a lot easier. We actually worked with gamers to help us map how to make it move, so that it's consistent with video games and makes it easier to pick up.
So it's very interesting that they're using games and game methodology in order to control these robots. Now, on the next slide, what we wanted to show you was how much the porousness of this has really come together. And Richard and I went to a couple of shows for the military, and basically these are all controllers that are being used to control either UAVs or military ground robots, and they're all based on game controllers. Every single one is actually based on like a Sony or a Xbox joystick.
This one on the right is actually an off-the-shelf Logitech game controller.
Yep, an off-the-shelf controller. Some of them are just modified, but we saw most of these at AUVSI. We actually snuck our way into the drone show, and that brings up the next thing, which Richard is going to talk about, which is drones and UAVs.
More video games.
More video games.
So we're going to dive into drones and UAVs here. I would like to just roll a few clips of aerial UAVs and their user interfaces as we've seen them depicted in video games. Okay. So can we guess what's next?
I'll bet you can.
3D robotics, Y6 autonomous UAV. So 3D robotics is a company based in San Diego, and they're involved in designing and manufacturing low-cost, semi-autonomous drones for the commercial market. And they currently offer an array of vehicles built around 2 autopilot systems. And one is the open source Articopter platform, and the other is the Pixhawk, which is designed by the PX4 Open Hardware Project. And we recently acquired one of these platforms for the purpose of aerial photography, but also to really kind of test the waters ourselves with regard to like what is the current state of the art for commercially available autonomous craft, like what can we actually do with this thing. So this is some video of Alan and I actually out in the field testing this and playing with it, more playing with it than anything. So it automatically downloads maps from Google Maps based on the GPS position of the craft. There's an onboard GPS. In the upper left, that's the real-time telemetry link from the craft, and that's a real-time video feed that we're recording. And it's amazing. It's all controlled with a really simple point-and-click, very game-like interface where you can literally, like, once it establishes a GPS link, you just pull down the Google map and you set waypoints where you want it to go and upload those waypoints to the craft, and it flies there.
So once again, we wanted to talk about, we wanted to bring up William Gibson. And William Gibson actually has a very interesting quote. He says, "The street finds its own uses for things." And basically, that's really what we're talking about here, is that we consider ourselves to be kind of just individuals who want to go out and use this technology, that we don't want to be just the domain of the large corporations or the Defense Department. So we're insane enough to basically, get hold of that technology and basically take it out into the world and find our own use for it. And we're using it in all different kinds of ways for, like he said, photography, things like that. So I'll let Richard talk about the conclusion.
No, you're up.
Oh, okay. So what does this mean? Why did we show you all this stuff? Well, I think it all comes back to that German word durchlässig and porousness. And we're very interested in porousness, and we're very interested in how these technologies essentially interface with each other and how they cross-pollinate. And the best way for us to do that is not to look at them as an abstraction and read white papers and all of that kind of stuff, but we have a unique opportunity working in the entertainment industry and having kind of the permits that we do to do certain things to go out and get this kind of technology and to put it to use and to find out what can we do with it as individuals. How can we use it? How can we augment our space with it? And that's really what we're doing. So it may seem a little bit crazy, but to us it's sort of like, we want to see that porousness from the video game world to the real world be crossed over.
And we believe that it's important for all of us to see how each of these different disciplines influence each other, from science, engineering, design. I mean, they can all in fact relate to and influence each other, in that creativity and innovation can accelerate, I think, when we break through the dividing walls in politics that often separate these industries. And the important takeaway here for us is identifying and nurturing that feedback loop that starts with, I think, imagination and moves from an idea to a reality that then spawns the next generation of imagination and innovation. And this is, I think, what we really mean when we're talking about that porous nature. It's less of a linear evolution and progression than it is a cyclic sort of reinforcing influence. And it's important to never stop looking for relationships and crossover between seemingly incompatible things, because out there at the edges, when the walls do break down along those borders, that is where we think new synergies can occur and where really interesting things do indeed happen. Thank you.
So thanks.
Great, guys. Thank you very much.
Cool.
That wasn't so crazy, man. It was okay. Thank you very much. Just for instance, if you're going to Germany next time, gaming and war games are not so not so good here in Germany. It's just a short notice. Okay, thank you very much, guys.
Thanks a lot.
And as you can see, Fabian is taking place already, so we ran out a little bit of time. So let's move on. And while he's preparing his presentation, let's show an old presentation of Fabian Hemmert. And he's doing really cool stuff, and now everything makes sense. Everything you've seen before makes sense with Fabian Hemmert, because we see lots of virtual stuff, the virtual magical stuff you can't feel and you can't sense just watching it. Fabian actually is working on making everything haptic. And this is quite astonishing, so let's roll out the movie, please. So, and Fabian, you are a PhD candidate, actually, at the Design Research Lab here in Berlin. Okay,
True.
And you did a TED talk.
Yes.
And that's nice.
It is.
Yeah. It's not so cool as the Medienwoche, but TED is cool as well. Yeah. Okay, this is a small movie, and as you can see, the resolution is not 4K. It's like
VHS.
One something really bad. But actually, this is old work from you, right?
Yeah, it's also in this talk, actually. I'll talk about that. Yeah,
okay, so welcome, and give it a short applause for Fabian Hemmert.
Thank you.
The stage is yours, Fabian.
Thank you very much. Here I am. So when I was a little boy, I actually wanted to become a magician. And it didn't quite work out. However, what fascinated me about becoming a magician was working with the impossible, making things that do not exist a reality. And I ended up in design research, and there's a parallel, because also in design research, I have to do things that do not yet exist and make them a reality, so we can try it out. So my research is all about how our body, let me just plug in this here, how our body understands the digital world. That's my research question. Because when we look at people interacting with the digital world right now, for many of them it's quite complicated. And when I've worked all day, I still have to go to the gym because I haven't done anything. And then these people in the subway and on the bus, it's almost an addiction. And I think part of the problem is that in interaction design, we focus too much on the head and not enough on the body. Too much on thinking and understanding. It's very cognitive, and not enough on just doing and feeling, maybe even. Think of swimming or riding a bicycle. That's really complicated stuff, but we can just do it without thinking about it, because our body has understood it. Hence the question, how does our body understand the digital world? So we can fit better interaction to the body. Sadly, we cannot ask the body, because we always speak consciously about it. However, sometimes we speak about the digital world and use bodily metaphors that kind of, tell anyway how the body understands the digital. Let me give you some examples. When I feel buried under emails, you know what I mean. It's just a metaphor. There's nothing burying me. But it's loads of emails. They're all in my inbox. They're all on top of me. I can't move. It's not a good feeling. And it's a bodily feeling I describe using, the metaphor. Or when I say, we do some data mining here. That's also a metaphor. Because there's a lot of data. There's some good stuff in there. And it's pretty hard work to get it out. My favorite one is this one. My hard disk is not big enough. I know that my hard disk is a small box that's inside my computer. And when I say that I want a bigger hard disk, I don't want a bigger box. I want more, space in it somehow. Well, all I want to say is what's behind that is that our body seems to understand digital information like something physical, because that is what it knows. So what if we took that literally and maybe built a mobile phone that got thicker when there's more content inside and thinner when there's less content? Well, we tried that, and here it is. So it's thin, and it can be thick as well. And we put some motors on the inside, and it's pretty simple. And it brings up some very interesting concepts. So for example, it can be thin in the pocket when you have it in your pocket. And when you have it in your hand, it can be thick and lean towards you, adjusting the screen to where you are, basically. And often on mobile phones, we look on a small display, on a big piece of content, like a website or a map or something. In that case, there's a lot of off-screen content, stuff we can't see. because it's too small, like here. In this case, we could just feel, oh, there is some off-screen content up there. There's a lot of content. I can't see it, but I can feel it. So that's one example of what our hands are really, well, good at feeling. Another thing is weight. When I have this thing in my hand, I can really feel, okay, its center of gravity is pretty much in the middle. I can balance it like that. But if it's off-center, I can also feel that. And what if we built a mobile phone that could make, well, digital information feelable through weight? So that is the weight-shifting mobile. And it can shift its weight from the left to the right and from the top to the bottom. This could be the battery, for example. The battery is pretty blocky, pretty heavy, has to be somewhere inside the device, and we could just move it around. So this piece of content we can not only see, we can also feel it, which doesn't really make sense because we can see better than we can feel. However, sometimes we don't want to look at the device. And that is, for example, in navigation. So imagine your phone could guide you through the city, like ahead, oh, left, and then you would just feel which way you have to go. Like here. Oh, okay. So that's another thing we are really sensitive to. And a third thing, which is very interesting, interaction design. I mean, the usual goal in interaction design is to make it as smooth and easy as possible. However, whatever we want to feel has to resist us in some way. If the table doesn't resist me, I can't feel it. So we thought about the touch screen, and usually you don't feel anything. It vibrates maybe, but that's it. So we built a touch pen that can increase the friction on the surface, like this. It's like a rolling ball in the tip, and we can stop it. So if you go through a news website, you actually stick to those items that are more important. It's hängen bleiben, also in German, very good metaphor. Or for example, when you spend money online, when you do your signature, you could feel how much money you're spending. So that's like nothing. However, now in this case, you really have to work that signature. It's like, oh, come on. And I like that more than the question, do you really want to do that? Yes, I know what I'm doing. Like, while you're doing it, feel that it has consequences. This is like magnetic guidelines, which is also, of course, possible. So that's one metaphor. Information as something physical. And that's very interesting when we look at another metaphor we use, and that is for information consumption, like news, reading, social media. Here we use a different set of metaphors, which is related. For example, I speak of, well, when I want to go easy on Facebook this weekend, I'm putting myself on an information diet, which is interesting. And also for stuff that's nice but not necessary, we use the term eye candy. And we speak of food for thought. You see where I'm getting with this. And maybe that's hard to swallow. In German, we also have leichte Kost and schwer verdaulich, which is also, it's food metaphors all over the place. Our body seems to understand information consumption like eating. There are loads of parallels. And that is historically very interesting, because when we look at how our eating culture has changed, think of the 1990s fast food explosion. That was like ubiquitously available, kind of tempting. We stuffed it in without thinking about it. Then, oh, was it really good for me? Maybe second thoughts, but half an hour later, we're hungry again. What happened then was more selective approaches, like vegan eating or splitting up food by the ingredients, like carbohydrates, not in the evening, makes you fat. Setzt an in German. And more aware approaches, like, okay, this food, what's in it? Where does it come from? What will it do to me? Maybe with information consumption, we are in the fast food era right now. It's very tempting, everywhere available, you would just take out the phone. It's kind of tempting, you stuff it in, and then maybe you ask yourself, was that really good for me? Was it worth it? And then, well, 5 minutes later, we're hungry again, we want more. It's even all you can eat. It's even worse than fast food in the 90s. Maybe also here we need more selective approaches, don't consume everything, more aware approaches, like what's in it, what does it do to me, is it worth it? And yeah, I think today the most limited resource we have is not time anymore, it's attention. That's what we have to be like really sparsam with. And well, I don't have a project for that, but I think that's what we need. The third set of metaphors I find the most exciting, and that's how we speak about our devices. When I say that my phone is almost dead, which we say when like the battery is running out, it sounds like it was alive before, right? Which it isn't. So, and when phones got more functions one day, we started calling them smartphones, which is also a metaphor. The smart thing on this planet is us, by far. And that's good. But somehow, like, to explain this intelligent behavior, we lift them on our level. I don't know why, but we do it. And I'm not sure about you, but sometimes I have the feeling that the relationship between my computer and me is somehow disturbed. You know, when it crashes right before I wanted to save my work, it has to do that intentionally. Now that's actually also a metaphor. It's like devices are like social beings. That's also how our body somehow seems to describe these things. And that's something we also took into a project. What if we built a mobile phone that would like live in the pocket, the living mobile phone? Let me show you the prototype. So this is a mobile phone that has a heartbeat and a breathing motion. It's very calm and relaxed right now, which as a user tells you, no missed calls, no text messages, everything is fine basically. But then it gets excited. Oh, a missed phone call, and that would like in the pocket, oh, it's exciting. No, it needs my attention, you know? And that's how you like calm it down again, behind the ears, and it works a whole new like interaction paradigm. And in the follow-up project to this one, we looked at something else, and that is body language. We humans are really good at body language. I can be like open, I can be like, oh, I'm a bit scared. I don't have to think about that, and neither do you. We just do it all the time, we do it really well. And technology doesn't. A mobile phone would just sit there on the table, and when I reach out to it, it doesn't do anything, you know? It's just dead. Now, what if we built a mobile phone that could, when I reach out to it, react to my hands through body language and tell me what could it tell me? Maybe I haven't checked it for a while, and it's like, oh, nice to see you. It comes towards the hand, and it's like delighted to see me as the user. It recognizes me maybe even. However, maybe when I've checked it 5 minutes ago, maybe it's not overexcited about me, you know? It's like, oh, you again. So, and maybe when I checked it like a couple of times in the last minutes, it's even annoyed by me. And that's what body language is really good for, like relationship stuff. Now what we humans have around ourselves is this public space, there's a private space, and a very intimate space. We don't let everyone in there. Maybe also a phone could have the same. Maybe I feel that, oh, it's scared of me, so I have to go slowly and like gain its trust, and it recognizes me. And then I feel, oh, now you recognize me, it's fine. And it's fascinating. I mean, this is just plastic and motors, right? But it tells a whole story of, oh, it likes me, it doesn't like me, it's annoyed by me. Interesting. So that's my job. And it raises some questions. I mean, do we really want technology that has an opinion of us? That doesn't want to be used at some point? I don't know. Or maybe we do want technology that kind of executes every command we give it. Like sitz, Platz, Männchen, sit, stay, and stand. I think that's in English. Well done, yeah. It also raises other questions, and that's, I think, the important questions of these days, and that's, like, what do we want the relationship of humans and technology to be in the future? Do we want to meld the two together, or do we want to draw a clear line, human-technology? Do we want to understand our lives, continue understanding our lives, like a software program, from status update to status update to status update? That's a software metaphor. Or do we want to start living moments again without documenting them and without letting technology get in between? It's all there. And then there are these moments, and they fascinate me, and I'm sure you know them too. It's moments of boredom, of weakness, and of solitude. It's fascinating because what we do right now about them is we kill them and we escape into telecommunication. As soon as it gets boring a little bit, every escalator ride, it's like, oh, what? Let's check the news. We escape into telecommunication because we don't want to let this happen. But if everything becomes telecommunication, what about the here and now? And where are we? Because we're always somewhere differently. And maybe these moments of weakness, of boredom, of solitude, maybe they're also important for us. Because that's when we spend time with ourselves and reflect and develop ourselves further. They are uncomfortable, though. Now, there is a fourth metaphor lurking here. And if you go over the IFA, you will maybe see it in some places. And that is, humans are like computers. Always connected, never wrong, and so on. I don't think that's where we want to be. It's even my fear that in the future we would, at least psychologically, maybe even with our bodies, turn into a kind of Darth Vader. You know, a mixture of machine and human that's unable to exist without the machine that's part of it. I think it's really important that in the future we just don't turn into a computer, but stay human. Thank you very much.
Thank you, Fabian.
Vielen Dank.
Yeah. So this panel is called Media Science Fiction, and you showed us the first smartphone pet. It's like you can name it maybe and go and get some food maybe, and then it walks out and gets some food. And nice and pretty astonishing. But you hooked up on a few philosophical questions like should men, stay human, stay biological, or should they enhance by using computer chips produced by companies and make them more powerful and stuff like that? What do you say, like Terminator, iRobot, and all this stuff? So you say, let's stay biological, it's better that way?
Well, I mean, we already, like, if I take a aspirin because of a headache, it's already technology going all through my body.
Yeah.
The question is, where's the border? And I think we don't know it yet. It's like
yeah, but
we're pushing the borders also.
Well, actually, it's interesting. Yeah. So we're looking forward to what's happening next. As we have seen right now, so we got 4 really brilliant speakers, or actually 5, I'm sorry, 5 speakers, and everyone got their certain direction in which they see we are going right now. So we got the virtual world, and we got different aspects and perspectives of the virtual world we are attracting. Now we got the haptics, and we're trying to, okay, let's do our smart devices even more haptic, and then we can relate differently to them.
Personally,
so, personally, yeah. But, and we have lots of other media still, books and films, and they are showing quite disturbing dystopian pictures, actually. So I think we can stay here and just relate to. I don't think that we be cyborgs or hybrids in the next couple of years. So maybe next year at Medienwoche we have different views, maybe. Yeah. So does anyone have questions to Fabian right now about the pet? The smartphone pet, maybe.
Come on, guys.
Maybe next year you can have sound like.
Yeah, that's a good idea, actually. Yeah.
Good. All right. So okay. So everyone is satisfied, and now I would say thank you, Fabian.
Thank you very much.
Thank you, everyone.
Thank you.
It's been a pleasure to have this glimpse into future, and I can tell just personally, those guys, they are far more beyond that what we heard today. So, and I would just love everyone, you in the internet and you as the audience, prepare for something really, really interesting in the next couple of years, because I think we are at the verge of something bigger right now, and it's getting faster. So, thank you very much for being here. Thank you, speakers. That's it for us. See you soon. Bye-bye.